Hi team, and welcome back to the Radical Rundown. I'm really excited about the show we have for you today because we're covering a topic that is one of the most popular topics ever discussed on the Mo Monday series with Mo Pinnell. It was the rule of N and how the dual angle ratios and dual angle sums allow you to choose the ball reaction and how soon it revs up and how soon it reads the lane relative to the angles that you choose on the ball. Now everyone is familiar with the dual angle layout system, but not everyone is familiar with the rule of N. If you'd like to go back and review that, it is still on the Radical Facebook and YouTube pages under the rule of N for Mo Mondays. Here on the Radical Rundown, we're going to expand that idea today, talking about the angle ratios, or the ratio of N if you prefer. You can see here, I've got 3 hitters in front of me. I chose these balls because they're nice and dark. They allow you to see the grease pencil on the ball, but also because they're asymmetrical balls. And remember, the rule of N is going to apply to asymmetrical balls because the first angle in the dual angle layouts is the angle from the mass bias up to the pin and then over to the PAP. On symmetrical balls, after drilling, the first angle is always going to end up with the mass bias, or the preferred spin axis, in the thumb of the bowling ball, regardless of where you put the CG on the ball. So that first angle is always going to be larger for symmetrical balls, even if you kick the CG out. So the rule of N really strictly applies to asymmetric bowling balls, which gives you the most versatility for layout options now that you can't use a balance hole. So we're going to start here with a review of the rule of N by putting some dual angles on this first one and talk about what the rule of N means. We're going to start where we always start, by drawing a line from the pin through the mass bias. This is referred to as the pin to spin line for many people. And this line is important because it kind of dictates how soon the ball revs up when it's in relation to your PAP. When this line is closer to your PAP in the layout, it means that the ball is going to rev up sooner. And when this line is further away from your PAP in a given layout, it means the ball is going to rev up later. So we're going to apply the first angle here. In this case, I'm doing a relatively moderate angle sum of 90 degrees. The rule of N states that shorter ends, aka smaller angle sums, result in a faster transitioning, faster revving ball. So an angle sum less than 90 degrees is going to rev up and transition faster than an angle sum greater than 90 degrees. On this ball, and on all the layouts we're choosing, I'm just going to use a generic 4-inch pin to PAP. In this video, we're really concerned about the angle ratios, and we're not so concerned about which pin to PAP position we're selecting. For the second angle here, I'm going to do another 45-degree angle. This is going to be the angle from the PAP that makes the VAL line. VAL, of course, is your vertical axis line, and this is the line that's going to represent the vertical coordinate of your PAP. So here's what a 45 by 4 inch by 45 degree layout looks like. Remember that this is going to end up being the bowler's PAP. Here's your VAL, your pin to PAP distance, and your first angle, in this case 45 degrees, and your second angle, in this case also 45 degrees. Now for completion, we'll just put the bowler's PAP coordinates on this ball and back out where the fingers and thumb are going to end up. The standard PAP on the Radical drill sheets is 5 over by 3/8 up, so what we're going to do is we're going to back that out. Because it's 3/8 up, we're going to go 3/8 down, and we're going to draw a 90-degree angle, and we're going to go backwards toward the center of grip. We're going to mark 5 inches for the horizontal coordinate, and that is our center of grip. We're going to draw a 90-degree angle to the horizontal PAP line, and that's going to be our center line for the layout. We'll, just for completion, mark roughly 2 inches for a span here, and in this 45 by 4 by 45 layout, that's roughly where the fingers and thumb are going to be. Now, this angle sum in the rule of N is 90 degrees. That's a very moderate N. And when we're talking about the N, we're talking about the line that's made from the mass bias up to the pin, across from the pin to the PAP, and then completing the N with the VAL angle. So there's your N. And one more time, Smaller ends make faster revving, faster transitioning layouts, and larger ends with larger angle sums are going to make slower revving ball motions. So now we've got you refreshed on the rule of N. This is an angle sum of 90 degrees, which is a pretty moderate response layout. Remember, a smaller N with smaller total angle sums is going to be a faster responding ball, and a larger N with larger angle sums is going to be a slower responding ball. But now we're going to give you some new information. What we're going to talk about now is the ratio of the angles. The 45 by 45 layout that we just drew on the previous ball is going to be a 1-to-1 ratio because the drilling angle, 45 degrees, and the VAL angle, 45 degrees, are equal. If you want a later revving and faster responding ball in friction, then you want a higher angle ratio. Using the same 90-degree angle sum, we're going to do a 2-to-1 angle ratio and make these angles 60 degrees and 30 degrees with the same 4-inch pin to PAP. So here we've drawn a 60-degree drilling angle. We're going to put our 4-inch pin to PAP position on the ball here. This is the bowler's PAP. And now we've got a 30-degree VAL angle. So although the total angle sum is still 90 degrees, we've got a larger drilling angle, which is going to let the ball rev up later than the 45-degree drilling angle. And we've got a smaller VAL angle of 30 degrees, which is going to allow the response to friction and the transition from hook to roll be quicker and sharper. So all we have left to do is to back out the PAP 3/8 down and 5 inches back to the center of grip. And we'll do that right here. Measuring 5 inches back to the player's center of grip, we've got a pin position that is higher relative to the center of grip and a mass bias location that is closer to the thumb relative to the center of grip than the previous layout. There's your fingers and your thumb. As the PAP migrates in transition, it takes a lot longer time to get to that pin to spin line, which is why it takes longer for this ball to rev up. But the shorter VAL angle makes up the difference with a sharper response to friction. So now we've got our moderate response layout, 45 by 45, our 2-to-1 angle ratio layout that's going to be a longer and stronger response, and all that's left now is to have an early revving and slow response to friction layout, and that's going to be a very small angle ratio. It's going to be 1-to-2, 30 by 4 by 60. So we're going to play the exact same game here. We're going to connect the pin through the mass bias. That is our pin to spin line. We chose an early revving drilling angle of 30 degrees. I'm going to mark that here. We're going to keep the same pin to PAP position of 4 inches. Marking that. That location is going to be the bowler's PAP. And this time we have a slow response angle on the VAL angle, a longer 60-degree angle. Marking that here. The VAL connects through the PAP. So that's what this layout looks like. You'll notice that the mass bias is actually outside the VAL, but that's okay. You never want the pin to go outside the VAL, but having the mass bias kicked way out like this is going to be a really fast revving layout. And you notice in the axis migration, the axis is migrating toward the center of grip, and that pin to spin line is still inside our VAL. So we have no problems with the direction of the flare spacing in this layout. We have our same 4 inches for our pin to PAP. We've got an early revving 30-degree drilling angle, and we've got a smooth and continuous response 60-degree VAL angle. This results in a 1-to-2 ratio of angles. All that's left now is to go down 3/8 for the bowler's horizontal coordinate and backwards 5 inches to get back to the center of grip. Remember, 5 over by 3/8 up is this bowler's PAP. So since we did the dual angles first, we have to go down and then back to get to the center of grip. Marking the vertical center of grip here, and then loosely marking 2 inches for a 2-inch span. Now you'll notice that with angle ratios 30 and 60, we actually end up with the fingers pretty close to the area of the pin. On a dot ball, this isn't going to be a problem. On a ball with a pin like this, then you might want to tweak the angles to either take the pin all the way out or just move it out of the way slightly. Make sure you avoid any cracking issues. But if you wanted a true pin down layout, you could make this angle ratio even smaller by increasing the VAL angle from something like 60 degrees to something like 75 degrees. That would take the pin down below the fingers as the final result. So just as a quick recap on the ratio of the angles, a 1-to-1 ratio is going to give you a moderate revving and moderate response to friction. A 2-to-1 angle ratio, or any high angle ratio all the way up to 3.5 to 1, is going to give you a later revving and sharper breakpoint because of the angle ratio. And conversely, when you have a small angle ratio, like a 1-to-2 in this case, or even lower all the way down to 1-to-3, then you're going to have a very early revving and smooth transitioning layout because the axis is going to cross the pin to spin line very early, but that big VAL angle is going to give you a long sweeping back end motion. Higher angle ratios are good for players with low tilt that need the ball to get down the lane a little better and kick more on the back of the lane. Lower angle ratio layouts are better for players who have higher tilt that need the ball to start losing tilt early and blend out the back end motion. And players that are in between can use a wide range of versatile layouts to fill out their arsenal. So that's all we have today on the Radical Rundown. We reviewed the rule of N and how shorter transitioning layouts result in shorter ends, and longer transitioning layouts are a result of longer ends. We also introduced the ratio of N, or the ratio of the angles, the first angle to the second angle, and how those help the ball transition earlier, later, with a sharper or smoother breakpoint depending on the angle ratio that you choose. That's all for us at Radical. Make sure you like and subscribe to YouTube and Facebook for the next Radical Rundown.